All right, welcome back to our lesson for binomial expansion, getting into the processes now for binomial expansion. And what we're going to cover is just expanding a binomial using the summary that we talked about last video, as well as just completing the square. Now, again, I have these guides for you to kind of follow what I'm doing, but I highly recommend that you go back if you have not already and look at the guided notes. There you're going to see a couple more examples, as well as a little bit more in depth of the notes and the processes that will make all of this make sense, such as Pascal's triangle for the binomial expansion. So again, the purpose of Pascal's triangle, of binomial expansion is to not have to multiply this out. I know a lot of students will look at x plus 2 to the fourth and say, all right, you know what, I'm just going to multiply this out. But the important thing that we can remember is the behavior of our powers, of our terms here raised to the fourth power. Remember, if we have x to the fourth, that's going to be the first term, right? And then the second term is going to be x cubed, plus then going to be x squared, plus it'd be x to the first, and then plus x to the 0. So if we understand that behavior of that first term always starts at that power and then goes in descending order. Whereas the second term is going to always start at 0 and then goes in ascending order. So that would be 2 squared, 2 cubed, and that would be 2 to the fourth. Okay? Obviously, 2 to the 0 power is going to be 1. And then the last thing we need to kind of cover is our coefficients. And that's where Pascal's triangle is going to come into play. So again, looking at our guided notes here, let's go and write this as, let's see, 1. That's like your base triangle here. And then as we get into a quadratic, a cubic, and again, you can just add these values to, 1 plus 2 is 3, 2 plus 1 is 3, and then you can just keep on doing that to get to more and more rows. And we're looking for the fourth row, 6, fourth, and 1. And you can see that fourth row is always going to, whatever the power is going to be the second term of your row for binomial expansion. So these are going to be my coefficients, so I'm going to put these in parentheses just so I can remember that that's what they are. They are the coefficients from Pascal's triangle. Okay. So now what we have here is we have x to the fourth. So 1 times x to the fourth times 2 to the 0. So that's just going to be a x to the fourth. Then we have 4 times x cubed times 2 to the first. Well, that's going to be we'll do this one. We'll break this one out. A lot of times it is sometimes helpful just to write them out. So therefore you can see this is 4 times x cubed times 2. Okay. In this case, we're going to have 6 times x squared times 2 squared, which is 4, right? So that'd be plus 6 x squared times 4. And then plus here we have 4 times x to the first. And then 2 cubed, that's going to be 8. So we don't really need to write an x cubed or x to the first, do we? And then we could plus, I don't know why I didn't put it else. Yeah, plus 1 times x to the 0 times 2 to the fourth. Well, 2 to the fourth is 16. X to the 0 is 1. So that's just going to be a times 16. All right, and now we can simplify this a little bit further. So this would be x to the fourth plus 8 x cubed. 6 times 4 is 24. X squared. And then plus 32x plus 16. Now, one other thing that I didn't cover in this lesson, I'm just expanding it all the way. But a lot of times we'll have problems that will be like, just find the third term or just find the second term. So instead of expanding everything, if you only need to find the second term, then just expand it to the second term. If you only need to figure out what the third term is, then just expand it to the third term. So those are kind of shortcuts. So therefore we don't have to do everything as in depth, or for taking it for so long. For the next one, I'm just going to do another row for binomial expansion because that's to the fifth power. So that's be 1, 5, 10, 10, 5, 1. I know it's going to start with x to the fifth. And let's see, that'd be y to 0 plus, let's see, x to the fourth, y to the first, plus, let's see, x cubed, y squared, plus x squared, y cubed, plus x to the first, y to the fourth, plus x to the 0, y to the fifth. And again, you did that right if you start with x, the first term to the highest power and go down to 0, and the last term starts at 0 and goes all the way to the 5th. Now I can just plug in my coefficients here. So that's going to be a 5. I'm not going to put them in parentheses just because we did that. I kind of showed where they kind of come from for the last one. Just remember it's multiplication here. And now we can just go and simplify this. So this will be x to the 5th plus a 5, x to the 4th, y, plus a 10, x cubed, y squared, plus 10x squared, y cubed, plus 5x, y to the 4th, and then plus a y to the 5th. And again, you can kind of see that symmetry that is going on with those coefficients as well as with the powers. All right, so for the next one, you can see that we have some coefficients. Now, when we have coefficients, it's going to be very important to use parentheses because we're not just taking the x to the power, we're taking 2x to the power. We're not just taking 1 to this. This is actually a negative 1. So a lot of times what I like to do when I have a problem like this is I'm going to rewrite this using parentheses. Okay? So now our first term is going to be 2x and our second term is going to be a negative 1 because our binomial expansion, the way that I'm teaching it, is going to be the addition of those two terms. So if you have a subtraction, just rewrite it as addition with a negative number. And this one's also going to obviously have some more multiplication we're going to need to do here. So let's do our next row. So that'd be 1, 6, 15, 20, 15, 6, and 1. All right, so make sure I try to use as much real estate as possible here. We're going to have a 2x to the 6th, right? And then we don't really need to write this 0, right? You guys would agree that y to the 0 is kind of redundant. So we'll kind of go from there. And then we'll do a 2x to the 5th. And then we'll do a times negative 1 to the 1st. That's just going to be negative 1. Plus, again, we have a 2x to the 4th. And this will be a negative 1 squared plus a 2x cubed, and then this is going to be a negative 1 cubed plus a 2x squared, and this would be a negative 1 to the 4th. And you can kind of see it's, once you kind of get this pattern down, it's just rewriting everything from here. Now, a problem like this, you would see it would probably be a good example of one where you just want to find like one term. It's like we don't really need everybody to do. That's going to be to the 0. So therefore, this would be negative 1 to the 6th. Okay. Now, you can see that's a lot of writing out, but that's going to be every single term. Now, the only other thing we need to remember, which a lot of students forget, is to include these coefficients. And again, another way to kind of check if you're doing this right or wrong is if you have a term that doesn't have a coefficient, then you made a mistake. So 6, this is 15. This was what, 20? 15, 6, and then 1. Okay, now it's just going to kind of come down to simplifying everything. So 2x to the 5th. So again, we need to kind of go back through here and 2 to the 6th, which is going to be 64. So we'll have a 64 x to the 6th. I'm going to simplify this one more time. So this would be 32. So it would be 6 times a 32. Oops. Now let's just do times 32 x to the 5th. Now, again, we got to be careful here because this is being multiplied by a negative, right? This is a negative 1. So actually what I'm going to need to do is not do that as a positive, recognize that as a negative. So that's a negative 6 times a 32 x to the 5th. Here, I'm going to have a plus a 15, 2x to the 4th. That is going to be, that's going to be to the 16th times 16 x to the 4th. I'm not worried about it being negative because, again, my negative 1 here is being squared, right? So it's going to be a positive. So again, anytime you have a negative raised to an even power, it's even. Anytime you have a negative raised to an odd power, it's going to be negative. But again, like the value of 1 is not changing actually the value of our expression. That's just going to be changing the positive and negative. So then here we have 20, and this is going to be times a 8 x cubed plus a 15. Oh, sorry, that's a negative. Why do I keep on making that mistake? That's a negative, right? Because it's negative 1 cubed. So it's a negative 20 times 18. Then plus, that's going to be a positive. So it's going to be a 15 times 4 x squared. This is going to be a negative. So it'd be a negative 6 times 2x. And then here it's going to be a positive, so it'd be a plus 1. So now all we need to do is now just kind of simplify here. So this is going to be a 64x to the 6th minus 6 times 8 is going to be negative 180. So negative 192. Just double check my work. Yep, negative 192. 15 times 15 is 225, so that should be 240. Yep, so that's going to be a positive 240 x to the 4th. And this one's going to be negative 160 x cubed. That's going to be 60, so that'd be plus 120 x squared, negative 12x plus 1. Okay. Now for the next example, obviously you can see we're just doing one more, right? And again, we're going to want to use our exponents here. So this would be x plus a negative y quantity squared. Okay. We know that's to the 7th power, so I need to do one more row. So that's going to be 7, 21, 35, 35, 21, 7, and 1. Now the nice thing about this is also, since there's no other coefficients like this last example, I can just kind of go in and write in my coefficients and do my powers. I'm just going to make this kind of quick. The other thing I recognize is, remember, when you have a number, like when you have negative 1 raised to the odd power, it's going to be negative, right? So whenever my y is going to be to a negative power, I'm just going to make the term negative. I'm not actually going to write all this out. I'm going to kind of follow now these patterns. And the more you do of these, the easier this is going to be. So the first term I know is just going to be x to the 7th. Done. The next term is going to be that's going to be a positive. No, I'm sorry. Well, let's just write it out. I'll do the first one so you can kind of see. So this would be 1 times, let's see, this is a negative y to the 0 power, right? So that just gives you x to the 7th. The next term is going to be plus x to the 6th. Oops, I'm sorry. It's going to be plus a 7. That's going to be x to the 6th, and then negative y to the 1st. So you can see how that's going to make this negative, right? So rather than rewriting all of this out, which you can definitely go ahead and do, let's just follow this pattern. We're going to write our coefficients. So I know 1 is just going to make this an x to the 7th. There is no y because that's to the 0. The next term has to be negative. So that's going to be 7 x to the 6th. Because then it'll be y to the 1st. The next one is going to be a positive 21 x to the 5th y squared, right? Because I know my x's are descending and my y's are ascending. Whenever y is positive, my term's going to be positive. Whenever y is negative, my term's going to be negative. That means the next one would be y cubed, which will make it negative. The coefficient is the next number, which is 35. That's x to the 4th, and that's y cubed. And then we'll have plus 35 x cubed y squared, and then we'll do minus 21 x squared y cubed plus 7 to the x y to the 4th, and then my last one is going to be a negative y, because you can see that's being raised to the 7th power, and that has to be alternating. So hopefully you kind of see, like, the more and more you work on these for the expansion, the faster and faster it's going to be for you. Obviously you can always write it out for every single term, but it takes time. Or you could also multiply it out, but you can see that is going to take even more time. So I think understanding this relationship allows us to better understand what that polynomial will look like. But again, we recognize that, yeah, the binomial expansion is helpful, but sometimes we don't want something to be expanded out. We want to write it as a binomial. Now, we could look at this in terms of for solving it and completing the square. And we're going to cover completing the square in a couple different versions in this course. But for right now, I just want to kind of practice the idea of completing the square. And just so you can kind of follow along of how we can go from standard form to vertex form. So you have the guide, and also in the guided notes, I have multiple more examples for you to be able to kind of see how to complete the square. Now, the main thing we want when we're completing the square is making sure that our quadratic term, our x squared, has a coefficient of 1. As long as it has a coefficient of 1, what we're going to do is just basically look for what is going to be the value that completes the square. Now in this first example, we have a pretty easy one because this is actually already factorable. This is a perfect square trinomial, and that is what completing the square does, is creates a perfect square trinomial. This can be factored into x minus 1 times x minus 1, and that can be rewritten as x minus 1 quantity squared. And there we go, we completed the square. In this next example, we don't know, this is not a perfect square trinomial. We cannot write it as a binomial squared. So what we want to do is identify the value c that completes the square. Now, sometimes students recognize that this is what we call a perfect square trinomial. So what value would make this a perfect square trinomial? And if you made your guess of 4, you would be absolutely correct. Some students remember the perfect square trinomials, and I would recommend that you do that. But some students do not remember and forget, and they don't like factoring. So the easy way to always understand how to identify the value c is to take b divided by 2 and square it. So in this case, 4 divided by 2 is 2. 2 squared is 4. Now again, remember though, we just can't add a 4 on an equation and say that's fine. Whenever you add a 4, you have to make sure you subtract a 4. Okay, so if we're trying to keep things on the same equation, you can either add a 4 to both sides, or you can add and subtract on the same side. The important thing is, now I have a perfect square trinomial. So therefore, this can be written as x plus 2 quantity squared minus 4. And now we can identify this vertex. And remember, the vertex of a quadratic is going to be hk, which I forgot to do over here. So the vertex in this case is 1, 0. The vertex in this problem is -2, -4. Okay. Now in this last example, at least for these easier set of problems, we recognize this is not a perfect square trinomial. And so what we want to do is just look at these first two terms. And again, kind of go back through that guess and check here. What number would I need to add? What value c would I need to add to make this a perfect square trinomial? And again, if you think about this, what number multiplied by itself adds to give you -6, right? And what would that multiply to be? Well, that's going to be 9. And again, you just can't add 9. You'd have to subtract 9. And then we have a plus 8. So in this case, we have x minus 3, quantity squared, minus 1. And again, all I did from there is I took this trinomial and I factored it down. So completing the square creates a perfect square trinomial that we can now factor to a binomial squared. So therefore, the vertex here is 3, -1. Again, we can do the same thing over here by adding a value. Now this one kind of looks confusing because what are we going to do here? What number do we add, or what number that we multiply by itself adds to give us 3? And it's not very cut and dry in this example. So here's a great example where taking the value b, dividing by 2, and squaring it is going to make sense. So if we take 3 divided by 2, which is just going to be 3/2, and square that, that's going to be 9/4. So therefore, we have x squared plus 3x plus a 9/4. Then, remember, if you add 9/4, you need to subtract 9/4. Now, how am I going to factor this down? Well, that's a little bit more confusing, right? How do you factor the x squared plus 3x plus 9/4? And the simple answer is, when you're, rather than trying to think of what two numbers multiply to give you 9/4 and add to give you 3, you can also think about this as a binomial squared as x, plus or minus the b divided by 2 squared. So if your b divided by 2 is positive, then the binomial squared is going to be x plus b/2. If your b divided by 2 is negative, then it'd be x minus b divided by 2 squared. So my b divided by 2 in this case was 3/2 quantity squared. So the factored form is going to be y equals x plus 3/2 quantity squared minus 9/4. And again, think about it. Does 3/2 times 3/2 give you 9/4? Yes. Is 3/2 plus 3/2 equals to 6/2, which is 3. So you can see how it works. And then in this case, our vertex is going to be -3/2, -9/4. All right. For the last two examples, the only difference here is we have a coefficient here for our quadratic term. So we're just going to want to make sure we factor out the negative in this case, and in this case, factor out the 2. So we can see that this looks very similar to a quadratic, and there's a couple different ways to do this, but I'm just going to focus on, again, identifying those first two terms. So if I factor out a negative, I'm going to get left with x squared minus 8x plus 16. And again, what number multiplied by, take my b, take my 8, divided by 2 is negative 4. Negative 4 squared is going to be a positive 16. So I have a y equals, and actually negative 8 minus 16. I think that would work, I guess maybe. Yeah, it does. Well, you can factor out that. Let's just kind of go through this work here. So if you have negative 4, x squared minus 8x, yeah, that'd be a plus 16. But again, remember, if you're going to add a 16, you also have to subtract a 16. Now, the important thing that I wanted to bring up here is you're not actually adding a 16 here. You're adding a 16 that's being multiplied by negative 1. So when you subtract a 16, you need to multiply by negative 1 as well. And then we have our original 16 over there. So this problem actually comes into being a negative x minus 4 quantity squared. And then this becomes 16. That's going to be plus a 32. That is not correct. Yes, that was going to be negative 6 squared from on there. Yeah, that'd be correct. Okay, so you can see there, now my vertex, again, is going to equal 4 times 32. All right, and if we're going to do this again, you're going to do the same thing. Don't worry about factoring out the 2 from all of them. You can do it that way, but I prefer to use that method when I'm trying to solve. But when I'm trying to identify the vertex, which is going to be our primary focus in precalculus, you're going to want to factor out that first term. So in this case, you factor out the 2, and you're going to be left with an x squared plus 2x minus 1. Now again, we complete the square, take my middle term, 2, divided by 2 and square it. So I have y equals a 2 times x squared plus 2x plus 1. But again, you're not really adding a 1, right? You're adding a 1 that's being multiplied by 2. So when you subtract a 1, you need to multiply by 2 as well, and then subtract 1 again. There's that 1 from there. So now you can complete the square, which is a 2 times x plus 1 quantity squared. That's factoring that down. That becomes a negative 2 minus 1, which is a minus 3. So therefore, my vertex in this case is going to be a negative 1, negative 3. So I know, guys, it's a lot of work, a lot of practice to go ahead and work on completing the square, but this will set you up for future success for the rest of this chapter. So we want to make sure that you have the binomial expansion as well as completing the square down put. So hopefully you enjoyed this video. Go ahead and take a look at the quick quiz to check your understanding, and I'll see you guys in the next lesson. Cheers.